Hello everyone, my name is Joshua Lopez and today I'm going to explain the concept of arrays. Today I'll be using some of my own code from the labs to demonstrate key concepts related to arrays, including when to use them, how to process them, and how to use them with methods. So why use an array? So first we have to understand why we use arrays at all. So let's look at the M2 array challenge file. So if I wanted to manage a list of characters, like the ones in contains here, the contains method, I could create dozens of individual variables like char1, char2, char3, and so on. This could and would be completely unmanageable and messy. So instead an array lets me store all of those characters under a single variable name like char array, shown right here. It's the best way to handle a collection of related data, making code much more organized and efficient. So let's look at how to declare initialize array. So this method checks if a char value exists in a char array. So this is the value here. We're checking to see if it exists in this array. So the char array is a single dimensional array, a 1D array. So to check every element, we use a simple for loop as shown here. The loop counter I acts as our index starting at 0 and going up to, but not including the array's length. So that's why we have the less than here. The loop array I right here gives us access to each individual character, and we can check if it matches the value we're looking for, which is here, which is the value that was passed in up here in this parameter. So let me show you. So I ran some tests here in test demo. So it's just going to check to see if array 0 contains the character A. So that's the first test here. So you can see down here in the console. So it returns true here for A, and for B it returns true as well. And for capital C it returns true, and for lowercase c you can see here it returns false. So that's what that method does. So that was a single dimensional array, or 1D again. So a multi-dimensional array, on the other hand, is an array of arrays. A 2D array is often used to represent grids or tables, where each element has both row and column index. So we're going to look at the add all method here. So in Java, we declare with two sets of square brackets. As you can see here, this is an int 2D integer array, and it's named matrix. To process it, we use a nested loop. We use nested loops here. As you can see, there's a for loop here and there's a for loop here. So the first for loop is used to iterate the outer array, and the second one is used to iterate the inner array. So the outer array is the rows, and the inner array is the columns. So this lets us access every single element, like matrix, row, column, and perform an operation on it. So right here. So this will access every single element inside the matrix, and it's going to sum them up and store them to the variable sum. So down here you can see that for the add all method here, I passed in array 1, which up here doesn't have any elements inside, so it's going to be 0 because there's nothing in there to add. But here for JArray, it's going to add all the elements in there, and it's going to print them out. Here in test 2 you can see that for array for the first array, so it says array has 0 elements with a total value of 0, and for the second array it says array has 13 elements with a total value of 105. So you can see that it added all the elements inside the array. Next, we're going to look at how to write and call a method that has an array as a parameter and one that returns an array. And the perfect method for this is the copy method. Basically, it creates a new array of the same size, copies the element from the input array, and returns the new array. You can see here that it accepts a char array and its parameters. Then it creates a new copy array and initializes it with the length of the array that was passed in. And then here we check to see if there's any elements inside the array. If there are, we're going to go ahead and use a for loop to access those elements, and we're going to copy those elements from the original array that was passed in into our copy array, and then once all that's done, we're going to return it. So here you can see that there's array 2 with EBC. So it's going to, I'm going to call the copy array. It's going to get passed into this other array called array 2 copy, and then I'm going to, you can see here when it's ran, you can see that array 2 it's equal to EBC, which is right here. This is array 2. And then array 2 copy, it's going to be the same, so you can see that they're clearly copies. And then we're going to change array 2 copy. We're going to change its first element to A. And you can see after calling them again, you can see that they're completely different. So array 2 is EBC, and array 2 copy is going to be ABC. So that's the copy method. So next we're going to look at why 2D array is a great way to represent an image, and this is because an image is a grid of pixels. This structure maps perfectly to a 2D array. And you can see here, this is the image that we use for the lab, and if you zoom in, you can see that it is composed of a bunch of pixels and in rows and columns. So let's go look at the code in logic.java, and here in the code, the images pixels are stored in a 2D pixel array called pixels 2D, and then we have nested loops, which allows us to access every single pixel using its rows and column indices, and then we can easily apply a filter to each pixel, like inverting the color values to create a negative effect. And you can see here we have 255, which is just the colors number representation, which we subtracted with the current pixels values like red, green, and blue, and then we subtract it, and then we set it, and then we get a opposite value, and then we get images like this. So you can see here, this is the negative of the original image. This is the power of 2D arrays. Anyways, that concludes my explanation of arrays. I thank you for watching.